Hello mathematicians and welcome to How to Scale. So scaling is something that you've probably already done in other math units, but it is something that is used when you want to take a building, a larger image, and you want to make it smaller and like, for example, you want to take a house and put it on a piece of paper. Or you can go backwards. You can get a piece of paper and you can build it. So it's taking one image and enlarging it or shrinking it. Something that's commonly used in architecture, artists, construction workers, and the list goes on. So there is a general format. So usually when you scale something down, you do it by a certain factor. So maybe you shrunk it down by half or by a third, or maybe you enlarged it by double, by triple. That is a scale. So there is actually two ways you can write this. The first one is in fraction form. And the way that we do this is that we take the new size and we divide it by the original one. And then remember that we reduce. So here I'll put reduce. We reduce as much as possible, okay? The ratio, which is the second one right here with the two semicolons, is very similar. We take the new and we put these two semicolons and then we put the original size. With the ratio, we also want to make sure to reduce. And that is all we need to know. So I'm going to go ahead and try this first problem with you guys. So right here, we have a scaled drawing. So let me get my highlighter. A scale drawing of a spider is 5 millimeters long, and the actual spider is 10 millimeters long and 5 millimeters wide. What is the scale of the drawing, and how wide should the drawing of the spider be? So right here I have my two spiders, and to use this formula, I need to know which one's the new one and which one's the original one, okay? So my scaled one is a spider that's 5 millimeters long. This one's 10, this one's 5. So that means that my drawing is technically the new one, right? It's the one we created. And this other one is the original. This is the actual spider, okay? The first question is asking me by how much did I scale it by, okay? So we have to be consistent when we're scaling. So if I'm going to be looking at the length of my original spider, I also have to be looking at the length of my new drawn spider, okay? Similarly, if I'm looking at the width of my original spider, I also have to be comparing it to the width of my drawn spider. And it's so it goes. For this case, I'm going to be looking at the length. Why? Because I actually have two numbers here that I can compare to. Compared to my width, I only have this one number, so I can't really do anything with one number. I need two for my formula. So remember that the formula is the new size divided by the original, which I'll put as OG. Not big either. So I'm just going to write this as a fraction. My new one is 5 millimeters long. And my original one, my actual spider, is 10. So now I'm going to go ahead and reduce. And by looking at this and knowing your times tables, you know that we should reduce by 5, okay? So this is equal to 1 over 2. And this is my scale factor, okay? So remember, there's two ways to write this. You can either write it as a fraction or you write it as a ratio. So the way you write it as a ratio would be like this. So that means that I took my spider and I halved the size and I drew it, right? Makes sense. I had 10, I halved it and it became 5. Remember, this is a two-part question. The second question asks me, how wide should the drawing of the spider be? So we were saying earlier that I couldn't do anything because I did not have this number right here. Well, we get to find that number. So remember that with scaling and proportions, we have to be consistent. So if I went by halving with my length, I also have to half by my width. So that means that my new width, remember width is the bottom one, is going to be my original one. And I'm going to multiply it by my scale. So I'm going to half it. Or in other terms, in other words, I'm going to do 5 divided by 2. And if you get a calculator, you will get that this is equal to 2.5. But remember, we have to use units because this is a real life scenario. Is it 2.5 inches, 2.5 miles? Well, if we notice, we've been using millimeters with my new drawing. So this is going to be 2.5 millimeters. So I'm going to go ahead and try the third one now. So Percy drew a scale drawing of a hotel. A room in the hotel is 6 inches long in the drawing. The actual room is 24 feet long. What scale did Percy use for the drawing? So I'm going to go ahead and make a drawing of what's going on. So Percy's in a hotel room. So this is a hotel and Percy's in it. You don't have to draw this. So he has a room and he decided to draw the room. And he said that it was 6 inches long. Okay. So this is the drawing. Or in other words, it's the new one, right? But the actual size of the drawing, of the room, I'm sorry, is 24 feet long. So this is the original. What is the scale? They're asking us for the scale. So again, we're just going to use the formula. I'm going to take my new size divided by my original. And we're going to use our units this time. So 24 feet. And I'm going to divide it by 6 inches. Okay. 24 divided by 6. If I reduce down by 4, I get that this is equal to 4 over 1. And that's 4 feet and 6 inches. This is really important because he's measuring the drawing in inches and the room is feet. So it's a big difference. You have to keep this in the actual answer. So this is the scale factor. For every 4 feet, he drew 1 inch on his paper. And the way we write this as a ratio is 4 feet, 1 inch. And there we go. Go ahead and try question 2 and 4 on your own. I'm going to jump to the back and help you guys out with this one. So in this one, we are actually going to draw, okay? So we're given this original image. So we hear all the OG images. And we want to make the new one, okay? So before we were given OG and new, and we had to find the scale. Now we're given OG, the scale, and now we have to create the new one. So the way I read this is that this is a 1 to 2 scale. So that means that for every one box, I'm going to draw 2. Okay. So right here I have 1, 2, 3, 4. So instead of 4, I'm going to multiply it by 2 and I should get 8. Okay. So I'm going to go 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Right here I went down 1. But for every one, I'm going to draw 2. So I'm basically doubling it. So I'm going to do 1 times 2 is 2. 1, 2. Right here, I went to the left 1, 2. But with my scale, I am doubling it. So that gives me 4. 1, 2, 3, and 4. I went down again 2. So same answer, 4. I'm doubling it. 1, 2, 3, and 4. I have another 2, This is another 4. 1, 2, 3, and 4. And then I have 1, 2, 3 on this side, but I'm doubling it. So I'm going to get 6. 1, 2, 3, 4, 5, and 6. So this would be my new scaled drawing. I took this original one and I doubled the size because it's 2, and I get this image. So go ahead and try out the rest of the worksheet or go on to Delta Math. It's up to you guys, and I'll see you for the other video.